Okay, so I know that your talks yesterday overran, and today you might actually be looking at some of the work I put up for yesterday. So I'm not going to do an awful lot today, and I'm not going to assign you homework either. It's been a long first half of this term, and I think that you really should just take the midterm to relax fully. However, if there is work that you're doing yourself that you feel like you want to just get ahead with stuff, there's absolutely no problem with you sending me questions over email or over Google Classroom. So I'm here if any of you want to do that. But I think we're going to stop after this last example here today for your midterm. You have subject talks on Friday that at the time that you would have had maths. So this is the last maths that we're doing in this first half of the term. So we'll stop here on page 38 when we're finished. And we've done lots of examples for homework, so I don't need you to do any extra examples. So some of you might have tried this yourselves. And if you didn't, if you want to pause the video and try it yourselves before we look at it, that will be fine as well. They've asked us to find the minimum value of this expression here. And I would hope at this point that you'd all recognize that this is a quadratic, and that when they ask us to find the minimum value, that we can therefore find the minimum point. Now there's an interesting thing that's happened here. They've said, hence find the minimum point, which means that we can't just use the fact that I've told you for finding the minimum point. We must use part one. This is a little bit annoying actually, but you have to answer the question as it's asked, which means they want us to do a specific thing. Anyway, I'll go through what we have to do there in a second. So the first thing here is that we know that this is going to be a times x plus h all squared plus k, and we know that we're going to be writing it in that format because they asked us for the minimum value. And a is the coefficient of x squared, so it's 0.0072. And that's fine, we'll just use that as it is. So let's look at what we need to do. Same as we've been doing all along. We're going to use 0.0072 times x plus h all squared plus k equal to the expression that's here, 0.0072 x squared plus 0.036x plus 0.052. Okay, again, you don't even have to write this down, but it helps us keep organized. So this will be 0.0072 by x squared plus 2hx plus h squared plus k, and we'll multiply through our brackets, 0.0072 x squared plus, multiply that by 2. Use your calculator to do that. 1272, because it's easy to make a mistake with the zeros. You probably double it, no problem. 0.0144 hx plus 0.0072 h squared plus k equal to 0072 x squared plus 0036x, I run out of space, plus 0.052. Now I want these to line up nicely. So my x squared terms are the same. So I'm happy with those. And next I need to look at my x terms. So the x terms are going to give me decimals, but I can work that out. 0.0144h is equal to 0.0, put my point in the wrong place, 36, and I divide across. What am I dividing by? This divided by the coefficient, 0.036 divided by 0.0144. You notice here, if you're not looking at the zeros, these are multiples of 12 in here, so we think it's going to work out nicely. It did, 2.5. So we'll start to feel a little bit happier when we get nice, neat numbers like this. My constant term then. So my constant term is everything without the x. All of this stuff here on this side equal to this on this side. My constant term will give me 0.0072 h squared. I'm just going to fill it right in now. save me some writing, especially with these long decimals, squared plus k equal to 0.052. Let's just put this into our calculator in one go. So 0.0072 bracket 2.5 squared. Some of you might be able to do that in your head. Well done if you can. 9 over 200, 0.045. So 0.045 plus k is equal to 0.052, which means I just need to do a subtraction. 0.052 minus 0.045. You don't need to write down these steps. You're just bringing something over to the other side. And we get 7 to the power of minus 3. That's what my calculator is writing it as. But we're going to do it like this. Okay. So 7 divided by 1,000. And now, they never asked us to write that in completed square format. But we wanted to do it anyway. So our quadratic can be written as 0.0072, that's a, by x plus h squared plus 2.5 squared plus k plus 0.007. And I'm going to write down both the minimum point and the minimum value. So my minimum point, I change the sign in the brackets, minus 2.5, and I just use this one without changing it. My minimum value is just the k value, 0.007. Now I won't get full marks for that because while I found the minimum value the way I'm expected to, they said hence, which means I must use the minimum value. We must use the minimum value to find the minimum point. What are they doing here? They're asking us to understand that my minimum value is the output of my function, or the y value. If I were to plot this on a graph, and they want us to find the x value. So what they want us to do is this. They want us to solve 0.0072 x plus 2.5 squared plus 0.007 equal to 0.007. Well, that's actually really easy though, isn't it? Because these guys will cancel each other out when we subtract them. We brought this over to this side. So that means we've got 0.0072 x plus 2.5 all squared equal to 0. And now I can divide by this. So divide by that bit that's outside the brackets. And because it's 0 on this side, when I divide across, I've got x plus 2.5 squared equal to 0. Then I square root both sides. Now I said if we introduce the square root, we have to introduce plus or minus, but it doesn't really matter because it's of a 0. So if I'm saying that x plus 2.5 is equal to plus or minus 0, then x plus 2.5 is of course just equal to 0. We bring this to the other side, so x is equal to minus 2.5. So what I've done there, what we've done in this bit here, is we've shown why the minimum point changes the sign, the minus 2.5. So let's write it down to conclude it properly. Our minimum point is x equal to minus 2.5 and y equal to 0.007. Okay, so if there wasn't enough room on the notes, there wasn't on mine, to take down that extra bit of work there, you might put it on an extra page or on a sticky note attached to example 7. I will say this, most of the time you don't need to do this work because we knew the answer straight away, didn't we? From the fact that we change the sign of what's in brackets and we don't change the sign of the other part there. Okay, so there's example 11 and the second part of it there. Thank you. Have a great midterm.